Hello student, today we will study vector product and its property. First of all, we will see what is vector product. Vector product is also known as cross product. So consider two vectors, vector A and vector B, and suppose theta is the angle between them. Let n cap be the unit normal vector to the plane containing vector A and B. So see this diagram, this is vector A and this is vector B. Theta is the angle between vector A and B. So the direction of vector product of vector A and vector B is similar to the direction of unit normal. Okay, the direction is perpendicular to the plane containing vector A and B. The direction of vector B cross vector A is exactly opposite to the direction of vector A cross vector B. Mathematically, the cross product or vector product of two vectors can be written as vector A cross vector B is equal to vector A cross vector B means the vector product of vector A and B is equal to the product of their magnitudes and sine of angle between them in the direction of unit normal vector. So therefore the formula will be AB sine theta into n cap. So the standard definition of vector product and cross product is the vector product or cross product of two vectors, that is vector A and B, is defined as the vector quantity. The resultant is a vector quantity which is equal to the product of their magnitudes, sine of angle between them, and their direction is perpendicular to the plane containing A and B. So their direction in the direction of unit normal vector. So this is the definition of vector product or cross product. Now next we will see what are the properties of vector product or cross product. First property we will see the vector product is non-commutative. What do you mean by non-commutative? If suppose there are two vectors, vector A and B, so their cross product A cross B should not be equal to B cross A. This property is called non-commutative property. So vector A cross vector B is equal to the minus vector B cross vector A, and by the definition of cross product or vector product we know that vector A cross vector B is nothing but AB sine theta into n cap. N cap is the unit normal vector. So minus B cross A, okay, that will be equal to AB sine theta n cap. So it means that B cross A equal to minus AB sine theta into n cap. So by this mathematical formula or mathematical derivation we can say that vector product is non-commutative. Now we will see second property of cross product or vector product. Vector product or cross product is distributive. Okay, what do you mean by that? See this mathematical expression, vector A cross vector B plus C vector is equal to this A vector, okay, cross product with vector with the addition of vector B and C. It is distributive. So this A vector will be distributed with B as well as vector C with cross product. So vector A cross vector B plus vector A cross vector C. So this vector A is uniformly distributed with cross product with vector B and vector C. So this is nothing but the distributive property of vector product or cross product. Now we will see the third property. Third property means if we take the vector product of two vectors, okay, if we take the cross product of two vectors and their magnitude, so it will give the area of parallelogram. It means that the magnitude of vector product gives an area of parallelogram. Suppose this is a parallelogram and we know that opposite sides of parallelogram are parallel and equal. Suppose this horizontal side is vector A along the direction of vector A and this width is along the direction of vector B. So the magnitude of this parallel side, this horizontal side is A, and the magnitude of this vertical side is B, and this vertical side is in the direction of vector B and this horizontal side is in the direction of vector A. Suppose the angle theta is the angle between the vector A and B. Suppose this is the theta and it is the angle between vector A and vector B, and suppose this is the perpendicular drawn from the point C to D, and suppose this is the height of the parallelogram. So it will form a triangle COD. Look at this COD. In this triangle, we can find out sine theta by using trigonometry. So in triangle COD, sine theta is nothing but opposite side upon hypotenuse. So in triangle COD or OCD, sine theta is opposite side. So opposite to that theta, the opposite side is CD, and hypotenuse, we know that this hypotenuse is OC. CD by OC, and CD is nothing but height. CD is nothing but height. Okay, sine theta equal to height. And what about the length of OC? Length of OC or magnitude of OC is B upon divided by B. So from here we can easily find out the height, and the height of the parallelogram would be B sine theta. Height of the parallelogram would be B sine theta, and we know that what is the base of the parallelogram? Base of the parallelogram is this one along the direction of A vector, and base, the magnitude of base is A. The base of the parallelogram would be A. So this is base and this is height. So we know that the area of parallelogram, the formula for area of parallelogram, base into height, and base is A and height is B sine theta. So the area of parallelogram will be AB sine theta. So suppose this is equation number 1, and we know that by definition of cross product, suppose there are two vectors, vector A and B. So that by definition of cross product or vector product, we know that A cross B is nothing but AB sine theta into n cap. N cap is unit normal. Okay, this is from the definition of vector product. Suppose we will take the magnitude on both sides. If we will take the magnitude on both sides, what will happen? If I take magnitude of this cross product or vector product, so magnitude of vector A cross vector B is equal to the magnitude of right hand side also. So magnitude of AB is AB sine theta, but the magnitude of unit normal vector, this n cap, is 1. So the resultant will be AB sine theta. So the magnitude of vector product between two vectors will be AB sine theta, and AB sine theta from equation number 1, the AB sine theta is nothing but the area of the parallelogram. So from equation number 1 and 2, we can say that area of parallelogram is nothing but AB sine theta, and AB sine theta is nothing but the magnitude of the cross product of two vectors. It means that the area of parallelogram is nothing but the magnitude of cross product between two vectors. So the magnitude of vector product gives an area of parallelogram. So this is the proof. The third property is the magnitude of vector product gives an area of parallelogram. Now we will see the fourth property. And what is fourth property? If two vectors are collinear, it means two vectors along the same line, okay, or parallel or anti-parallel. If we take the cross product or vector product of two collinear vectors, then the result will be 0. So for collinear vectors, their cross product will be 0. So we will consider two cases. In suppose case 1, when vectors are in same direction or parallel. When they are parallel, the angle between them is 0. Suppose these are two vectors, vector A and vector B, they are parallel, okay, or vector A and B are in same direction, so the angle between them is 0. So what about their cross product? We know that by definition of cross product, A cross B is AB sine theta into n cap, and we know that the theta is 0. If theta is 0, the sine 0 is 0. So sine 0 is 0, it means the whole formula will be 0 on right hand side. So A cross B is 0. Okay, so therefore vector or cross product of parallel vectors or vectors in same direction, that is like vectors, is 0. Okay, now we will consider the case 2, when the vectors are anti-parallel, going in opposite direction, when vectors are opposite. Okay, what about the angle theta when vectors are opposite? Suppose in case 2, if vectors are opposite direction or anti-parallel, their angle between them is 180, that is theta is 180. So we will see by pictorial diagram. This is vector A and vector B. They are anti-parallel. So the angle between them is 180 degree. If they are along the same line but in opposite direction, the angle between them is pi 180. So sine pi will be 0. Okay, sine pi is 0. Sine 180 is 0. So according to the formula of vector product, A cross B is equal to AB sine theta n cap. Here sine pi is 0. So again RHS right hand side of this formula is 0. So A cross B is 0. So it means that vector or cross product of opposite or anti-parallel vectors is also 0. It means that when vectors are parallel or anti-parallel, okay, it means when vectors are collinear, their cross product is 0. So this is the fourth property. Now we will see the fifth property. What will happen when the vectors are mutually perpendicular to each other? Suppose there are two vectors and they are mutually perpendicular to each other, okay, their cross product, yeah, their vector product is equal to their product of their magnitudes and direction of unit vector. So their cross product is equal to product of their magnitudes and direction of unit vector. So we will see it by mathematically. Suppose the vectors a and b are perpendicular to each other. When the vectors are perpendicular to each other, the angle between those vectors is 90 degree. So theta is 90 degree. Angle between them is theta is 90 degree. Okay, if theta is 90 degree, then suppose by this diagram, this is vector a and vector b, and angle between them is 90 degree. So according to the formula for vector product or cross product, vector a cross vector b is equal to ab sine theta. Theta is 90, so sine 90 is 1. Okay, sine 90 is 1. So sine 90 is 1. So we will get on right hand side a into b into n cap. A b means product of their magnitude and n cap means in the direction of unit normal vector or unit vector. So the statement become the vector product of two vectors is the product of their magnitude and in the direction of unit vector. So vector or cross product of two mutually perpendicular vectors is equal to the product of their magnitudes a into b and the direction of unit vector. So this is the property number 5th, okay, for vector product or cross product. Now we will see the property number 6. Suppose two vectors are equal, what will be their cross product or vector product? If two vectors are equal, then their vector product or cross products will be 0. When vector product or cross product of two equal vectors is 0. Suppose vector a and b are equal vectors. So vector a equal to vector b. Vector a equal to vector b. So in place of vector a, we can write vector a, because vector a equal to vector b. In place of b, we can write vector a. So a cross b is nothing but a cross a. So is by the formula of vector product or cross product, it will become a sine theta into n cap. Okay, a sine theta and n cap, but the vectors are equal. It means the angle between them is 0. So if angle between them is 0 for equal vectors, so theta will be 0, sine 0 will be 0, sine 0 is 0. So right hand side, this we will get 0. It means a cross b is 0. When vectors are equal, their cross product or their vector product will be 0. So this is the property number 6. Now we will see the next property. Okay, similarly we can say for the unit vectors also, these are equal vectors. I cross I, their cross product is 0. J cross j, their cross product is 0. K cross k, cross product is 0, because they are equal vectors. Now we will see property number 7. So property number 7 is vector product or cross product of two unit vectors. If we take two unit vectors, their vector product will be sine theta into n cap. N cap is unit normal vector, unit vector. Sine theta into unit vector. The vector product or cross product of two unit vectors is equal to sine theta into n cap. So we will prove it by mathematical. Suppose there are two unit vectors. Okay, a cap and b cap are two unit vectors. Suppose a cap and b cap are two unit vectors. So the formula for unit vectors, we know that a cap is equal to a vector divided by its magnitude and b cap is equal to b vector divided by its magnitude. By definition of unit vector, we know the definition of unit vector. Unit vector is nothing but the vector divided by its magnitude. So unit vector a is equal to a vector divided by its magnitude. Unit vector b is equal to b vector divided by its magnitude. Okay, now we will take the cross product of these two unit vectors. Okay, what will happen? Taking cross product of these two unit vector, so a cross b, left hand side cross product, as well as we will take the cross product in right hand side. So unit vector a cross unit vector b, unit vector a cross unit vector b is nothing but a vector divided by a cross b vector divided by b. So taking cross product on both sides, left hand side and right hand side of these unit vectors, so we will get unit vector a cross unit vector b is equal to a vector divided by its magnitude cross B vector divided by its magnitude. Okay, so we can combine that because A and B are the magnitude. So this is the product A into B, and numerator we will get A cross B, A cross B. Okay, so vector A cross vector B, and by the formula from vector product, or by using the formula for vector product or cross product, we know that A cross B is nothing but AB sine theta into n cap. So it will be AB sine theta into n cap. In denominator is also AB. So AB cancel out. So only the product of sine theta and unit vector will remain. So this product of sine theta and unit vector is nothing but the cross product of two unit vectors. Okay, A unit vector cross B unit vector is nothing but the product of sine theta and n cap. So here is the proof of the seventh property: vector product or cross product of two unit vectors is sine theta and n cap. Okay, now we will see the last property or eighth property of vector product, that is vector product can be written in terms of their determinant form. Vector product of two vectors can be written in terms of component determinant form. Suppose there are two vectors, okay, vector A and vector B can be written in component form: ax I vector plus ayj plus azk. Similarly, B vector can be written as bx I plus byj plus bzk. Ax, ay, az are the component of A vectors. Bx, by and bz are scalar component of B vector. If we take the cross product of vector A and B, we can write the cross product of vector A and B in terms of determinant in component form. So how can we write? So A cross B can be written in first row unit vectors vector I, j, k. In second row the component of vector A, ax, ay, az. In third row the component of vector B, bx, by, bz. So ax, ay, az, bx, by, bz are scalar component of vector A and B. In second and third row we have to write of determinant. In first row we have to write the unit vectors vector I, vector j and vector k. So in this way the cross product of two vectors can be written in the terms of component determinant form. So this is the last property of vector product. Thank you very much. So we have seen what is vector product and its property. Thank you very much.